We are now going to start working through the test review problems for the final exam. These first problems involve using the law of sines and cosines. Although you can't see this very well, I'm going to rewrite this in a minute. But before I remove this, even though you may not be able to see it, but it says for sides A and sides B, round it to 2 decimal places. So that's going to be important as we start working through this problem. So here, I've basically taken that information and rewritten it so you can see it. So this is a problem where we're given 2 angles and 1 side. So this is the angle side. And for that, we're going to use angle A. We can find very easily from knowing the 3 angles of a triangle equal 180 degrees. And then sides A and B, we're going to use the law of sines. So let's find angle A first. So angle A is very straightforward. You take 180 degrees minus 95 degrees minus 60 degrees. Once again, because the 3 angles of a triangle have to equal 180 degrees. So 95 and 60, that would be minus 155. Looks like angle A has to be 25 degrees. So let's go ahead. Here are, from the formula sheet, law of sines. There's 3 parts to it. So you have to choose which 2 parts you want to use. Since we know side C, we're going to have to use the law of sines involving side C. So let's just go ahead and find side A. So we use law of sines between C and A. So I know that angle C is 95 degrees. This is side C, so this is angle C. So the sine of 95 degrees over side C, which is 4, equals the sine of angle A, which we just found to be 25 degrees over side A. Now what I like to do with these problems, I a lot of times cross multiply. So we have A times the sine of 95 degrees equals 4 times the sine of 25 degrees. Almost run out of room. If I solve this thing for A, you end up getting 4 times the sine of 25 degrees over the sine of 95 degrees. So grab your calculator, make sure it's in the degree mode, because I'm going to figure out these trig functions, but the angle's in degrees. So I'm going to say 25 the sine divided by 95 the sine equals, and multiply that by 4. And it says it wants to round it to 2 decimal places, so it should be 1.696. So this 9 is my last place. Let me just write it here to make sure we can see it. 1.696. But we want 2 decimal places, so I look at the 6, this 9 gets bumped up, but it gets bumped up to a 0, which means the 6 gets bumped up. And that should be side A. Side B, I'll do the same thing using C's, except instead of the A's, I'll do B's. So sine C over C equals sine B over side B. So C is 95 degrees, side C is 4. Angle B is 60 degrees. So the sine of 60 degrees over side B. Now if I cross multiply and do various things, I'll go and skip a step. So to get B by itself, it's going to be 4 times the sine of 60 degrees over the sine. I guess I can do that again. So cross multiply B times the sine of 95 degrees equals 4 times the sine of 60 degrees. So once again, grab your calculator. 60, the sine, divided by 95, the sine, multiply that by 4, 3.477. So this 7 is going to get bumped up to 8 since we got the 7 here, so the final answer should be 3.48. Now I have the answers here, so as it turns out, thankfully, those are the correct answers. So that's problem 1, angle, angle, side. Problem 2, I'll just show you how I've rewritten it. So once again, in this case, here's what they gave us. They just said side A is 10, side B is 4, and angle A is 80 degrees. I just drew a little triangle to make it a little more clear. So the things we need to find are angle B, angle C, and side C. So what have we been given? This is a case, I call this the ASS case. And remember, ASS cases can have lots of ways to solve them. I like to think about it. I ask myself, is it matching or non-matching? Matching means I have side A and angle A. The same letters used twice. So I call this matching. And for the matching case of angle side side, we're going to have to use law of sines. And remember, angle side side matching, there can be no solution, which means 0 solutions. There can be one triangle that works, or there can be 2 triangles. So this is the case where it can involve a lot of work. And you don't know what you're going to have until you start working the problem. So let's go ahead, just use law of sines. So since I know this is angle A, this is side A, I know angle A, and I have side A and side B. Therefore, law of sines, I'm going to use the A and the B, because I know 3 out of the 4 of these things. So I know angle A is 80 degrees, so the sine of 80 degrees over side A, which is 10. Now I don't know angle B, so I just write sine of B, but I know that side B is 4. So now I can solve for the sine of B, multiply both sides by 4. So 4 times the sine of 80 degrees over 10. So grab my calculator, make sure I'm in the degree mode, put in 80, hit the sine, times 4 divided by 10 equals 0.394. So what I'm saying is the sine of B equals 0.394. What I really want is angle B. Well, the way I get angle B is I can take the inverse sine of both sides of this equation. When you have sine of B, if you want to get B, you just take the inverse sine, in this case of 0.394. So I'll go ahead and hit on my calculator inverse sine. And if I look, I should have looked at the instructions for the angle. It says type an integer or decimal rounded to 2 places. So I need to round this to 2 places. So 23, it looks like it's 23.198. So it's actually going to be 23.20 degrees. So that's B. Now this is going to be my first triangle. Later on, I'm going to have to check and see if there's a second triangle. There's no other way to know it than to check it, and we'll do that in a minute. Let's finish out what I'm going to call my first triangle. Matter of fact, maybe I'll label this over here. First triangle. So let's go ahead and now that I know angle A is 80, I know angle B is 23.20, I can find angle C by simply taking 180 degrees, subtracting angle A, subtracting angle B. So therefore angle C is going to be 180 minus 80 minus 23.2. Should be 76.80 degrees. So now the last thing I need to find for my first triangle is side C. Let's go ahead and do law of sines with A and C. So angle A is 80 degrees. Side A is 10. Angle C, we just found to be 76.8 degrees. Over side C. So if I solve this for C, I would end up with 10 times the sine of 76.8 degrees over the sine of 80 degrees. So I got my calculator, put in the sine of 76.8 divided by the sine of 80 and multiply that by 10, and you get 9.885, which we're going to round that to decimal places, 9.89. So here is first triangle information. So we know we have at least one triangle. Now, we have to see if there's a second triangle. So what I'm going to write the initial information is going to be for both triangles. So I'm going to say for my second triangle, A is 80 degrees, side A is 10, and side B is 4. In other words, the three things they've given me, if I have two triangles, are going to be the same for both triangles. and it's just this information is going to change if I have a second triangle. So what I have to do is go ahead and start solving for a second triangle. And here's how you solve for a second triangle. I go back for the first triangle. The very first thing I found was angle B. So what you do is, if there is a second triangle, you take that first angle you found, and I'm going to use this number to come up with the second possible angle B. Once again, this was in the lesson. So I'm going to call, for the second triangle, I always put a little tick mark here. So this means angle B of the second triangle. And it's going to be 180 degrees, subtracting angle B from the first triangle. So 180 degrees, 23.2 degrees. So this is going to be my new angle B. 180 minus 23.2. 156.8 degrees. So that's my new angle B. Now at this point, I'm still not for sure there is a second triangle. The next step will actually determine if there's a second triangle. So what I'm going to do now is, for my second triangle, I know angle A is 80. I know if there is a second triangle, angle B is 156.8. Let's go ahead and calculate angle C of my new triangle. So of course it would be 180 degrees minus angle A minus angle B. So if I do this calculation, and lo and behold, I get negative 56.8 degrees. Well, you cannot have a negative angle for these triangles. So this says, you know what? There is no second triangle. So for this problem, there's only one triangle, and these are the remaining dimensions. Okay, I'm going to stop now and start a new video.